Hello everyone, I am Devang and welcome back to another video of our project EDR. In this, we are going to see about our EDR agents, that is the desktop applications architecture and its component. Let's have a quick recap of our last video. In our last video, what we have done is about what is endpoint and why do we need to protect. So we have seen about an enterprise network where multiple PCs are connected and to the central server. And on individual, we are required to install what EDR agent, that is a lightware software which monitors their detect the anomalies or their processes, and that detection is sent to the central server where from that the all our networks, each and every endpoint and devices can be monitored, detected, and response can be automated from there as well. So we have seen it in very detail in the last video, also about our real world networks. And at last we have seen what phases of EDR. So in different phases we are building EDR, the endpoint detection response system. And the major two phases we have like discussed, that is phase one is about the EDR agent or the desktop application, and about the phase two is about remote or the cloud web console. So right now we will be working on phase one, that is a desktop application. So in this video we are going to cover that desktop applications, uh, about desktop applications architecture. So what are this? We are going to cover about monolithic architecture, decoupled architecture, about user session, the PyQt 6 dashboard, what it is, we'll see detail, and about Windows session 0, the backend service, the IPC interprocess communication, and the name pipes. And at last, what is the key learning of from this video? So first of all, the problem about monolithic architecture. It exists is most basic applications or usually are monolithic. It means UI and the backend logic. Basically, all our things are compiled or are written in the same file, same program, and all they run togetherly. So the one issue is here is single point of failure. It means if a user closes that window or either that UI is crashed, so the entire application or the program is terminated immediately. But for the security reality, it means our EDR agent is what a security tool, and we cannot afford downtime. That's why we want something like foolproof, that whenever if our UI also crashes, but something or the monitoring tool in the backend should work continuously without any interruption from the user side as well. So the solution exists here is about decoupled architecture. It means a decoupled split brain design. Here, as you can see in the diagram, we are having two different programs broadly, and which is the backend engine, which is it is running as a service, and the front end UI or the dashboard front end we are talking, and they are two different programs running in two different sessions also. And with the IPC bridge, we are communicating or we are transmitting data from one to another. So what is this? The engine is basically doing what? The background processing thing, the thread hunting, the process collection, telemetry data collection, and logging into our log file and sending that to our front end dashboard. The dashboard is something kind of visualization, what we can say, tool where the simple processes all are being collected from backend is being displayed there, and user can what view or interact to that processes, kill or terminate according to the need. So this is how it is going to look. And as a result, majorly what the output is going to be the fault tolerance. It means if a UI crashes or the windows is being intentionally closed, if you close the window of the dashboard also, then also in the backend, the security agent continues to run and without user interruption also. So this is how it is going to work as a security tool, as a powerful proof, what you can say, tool. So what is about backend daemon? It is running in Windows Session 0. So what is daemon? First of all, we should talk about this term. So in operating system, a daemon is what? A program that runs continuously in the background without interacting, without interactive user interface. So it runs in the background continuously and it doesn't have UI, user interface. So we often call this as something Windows services. And what exactly we are doing here in this backend daemon is about collecting the telemetry and logging it continuously. And why we have specifically used services? Because the biggest challenge here about for us, it was for collecting data of deep OS events also. It is required kernel level access, kernel level API calls, And for that, what we require is system level privileges, means administrative privileges. So that's why we are running it in the as a Windows service in the session 0. So it means it doesn't have any UI, but it runs invisibly, silently in the background, and it is started as soon as your PC gets booted. Even if no user logs in, then also the services starts. So this is the biggest advantage. And the auto startup mechanism here we are using. So for registering our backend daemon, the engine, as a Windows services, for registering we are using what Windows SCM, Service Control Manager. With this particularly we are registering it for as a Windows service as well as for the auto startup feature. So it can auto start whenever other services started as soon as the boot happens. And here you can see the listed number of services in our PC using the services and using the Windows R and the services.mcs. There also you can see this services currently running in your PC. So here you can see we have simple EDR daemon. It is a backend service name and all details about its executable path, startup type, and its description. All this thing you can see there. So next come to the what front-end dashboard. It is running its user session. It means it is in the different session compared to the backend. So what it is exactly? So it is the IQT6 GUI used to visualize or a dashboard to for the real-time telemetry alert and to interactive response commands. Okay. So what is PyQt6? So Qt6 is the C++ framework used for user interface, creating user interface GUIs, and it is very powerful. How it is like a high performance, cross-platform, and C++ based. So Qt I am talking about. But PyQt is what we are coding in Python, as I said. So for that Python bindingness, we require Python binding, and it is the Python binding for Qt. PyQt, Python for Qt. So it is its version PyQt 6, sixth version. So this is about PyQt6 and why not a service? So we are running, it is a session 1 rather than session 0. Why? Because Windows enforces what session 0 isolation. It means services are strictly forbidden from drawing UI windows or popping up their what users like screen on users screen. So the services are not allowed to have a UI basically. So that's why our dashboard is something UI where user can interact, see the things and interact with that. So we require to run it in the standard user session. That is the session 1 basic reason. And one more thing, along with the dashboard, what here we required is the desktop icon integration. The icon, have you seen like system tray icon? So in this image, as you can see in the right side, in your desktop, the topmost task bar is there, and in that you can see several on this arrow. You can see several apps are or the icons have been listed. So these are called system tray icon. So why we required it? Basically to show that our backend service is running in silently in a proper way, connected and running it's doing its work, and also to access our dashboard or to open our dashboard instantly. That's it. And about auto startup mechanism, if I talk about, so we are running it session 1 instead of session 0. So that's why we are not using here SCM, Service Control Manager. Rather than we are using the concept of registry. So in the later on videos, you will be seeing how efficiently we can use registry and its path to like create the keys for our need in our project. So, because we have used about this registry various place in our project. So we will be seeing in detail later on videos, but for now you can see a simple path HKCU, and similarly HKLM also exists. So in that path the run keys is there, and in that we are like making an entry of our front end app such that it can start whenever the PC boots. So simply you can see the image of our front end, like in this particular, the run key of our registry. Here you can see two entries are been there. What is EDR agent GUI and security health, and it is the image of your task manager, the startup apps. Here you can see only two apps are being enabled there. So this is how you can check and verify how whatever the enabled or startup applications are been there. So in that way we are doing, and it is going to be a simple snapshot of our dashboard. We will be coming later on in detail about our dashboard and its functioning, but it is going to look something like that, where processes are going to look and we can interact with that. So this is simply about that, our front end. So let's talk about inter-process communication and why do we need a bridge? Because the problem, as I said, we are running backend in what session 0 and front end in what user session, the session 1. So window heavily isolate this both sessions and for the security reason. So that's why problem is they don't share memory. So no shared memory. It means we cannot share, they cannot share the Python variables with that. So how they will be interacting with each other, because we need to transfer data from one end to another. So we need something like that, fast, secure, and bidirectional bridge so that the backend can send telemetry to front end as well as front end can send active responses to the what our backend system. And as you can see in that simple diagram, from front end we are sending data to backend and backend to front end using as you can see interprocess communication, specifically Windows name pipe. So why we have used, we'll see it is in next slide. And we have created a simple name pipe and its name is simple EDR pipe. So why we have used name pipe? So Windows name pipe, you can, it is a syntax like slash slash and then dot pipe. In this you can create a name pipe, your custom name pipe. And why we have used name pipe only? Because biggest reason is it is native to Windows and it is, that's why, highly secure and lightning fast. Also, rather than going to the complex network sockets, we have used this simple or simplest approach for now for the creation of our EDR. And the data format we are using here is JSON payload. So in Python, JSON you can consider like a dictionary we use, key value pair, so that instantly UI can be like parsing the severities and event types and show to our dashboard. So it is going to be in very efficient manner. So the key takeaways and learning from this video are: first, the architectural shift, that we are moving from monolithic script to decoupled design that ensures that our security engine never stops even if the UI freezes or crashes. Second is privilege and persistent. So running the backend as session 0 Windows service, so it provides what invisible or silently running process and as well as the system level privileges so that it can monitor the deep OS events also. Next is we are running our front end in the session 1 and our back end in session 0. That's why OS isolation. Windows provides or enforces strict isolation between these both sessions. That's why they cannot share memory or they cannot even share the Python variables together. We need a secure bridge between both of these sessions, and for that we are using the inter-process communication and name pipe there. So using that we are communicating between both of them. So this was all about from this video. We'll meet in the next video. Thank you.